Hey, I'm Todd. I work at Google. I founded and still lead the ML SRE teams there, and I'm here to talk about SRE and machine learning, why it matters. I lied, I don't like that topic. I mean, that is the topic. The thing about USENIX is you submit your thing, and then 3 months later you think to yourself, what was it I was gonna say? Because there is a delightful, and this is actually good, because there's a delightful delay between when you submit a proposal and when the talk needs to be submitted. So the good part about that is you can just submit a proposal, and you should. Like SRE America's deadline is coming up in December, so those of you who feel like, I mean, California is not a great place, I don't recommend it, but you do you. You can just submit it, but when you come back, you're like, that isn't really what I wanted to do, and they do give you a chance to fix it, but by that point, you're confused and tired, so you don't fix it. But let's do SRE and machine learning. Does it matter? Because that's what we're all thinking. We're like, isn't there a way I could just not pay any attention to this? Let's just clean it up one more. Let's just put a little, like, does it matter yet? The yet is important. Many of us, not me, but you, sorry, not me. I already know the answer to this question. I'm just telling you. I'll tell you about it later. Many of us have the sense, this machine learning thing, it's out there. It's doing stuff. It seems like a lot of hassle. It's got a lot of hype behind it, so that means I should probably ignore it because things my bosses care about are probably not important to me because they'll go away eventually. So that's fine. But maybe I have to pay attention to it because it does seem to show up occasionally by people I like and respect, but not that often. So you sort of put it out of your mind every few years and you come back and you check on it. And you say like, does this matter yet? So this is your check. Sorry, this is your check for the last 2 years and the next 2 years. I'll tell you the answer and then you can decide what you want to do about it. An important note for this talk, this is a serious topic, but I am just not a serious person. There will be jokes. You may or may not find them funny. I find them hilarious, so I actually don't care if you laugh at all. Do whatever you want. But please note, I'm mostly not serious except when I am. There's no way to tell the difference. I'm so sorry. We're going to get through this together, I promise, and there is an end to this day. Okay, so laziness is a virtue. Everybody recognizes this, right? Laziness is a virtue. I am one of the laziest people I know. I really, really don't like working. And so I work for this company that makes a bunch of AI systems, and I'm about to give a talk about ML. So I'm like, fuck it, let the AI system write the talk, right? Cut out the human middleman. So that's what we're gonna do. The lawyers made me write up a disclaimer. It's actually an accurate disclaimer, which is, they really said that responses are still improving. That means they're not very good. Still improving. They are neither always correct nor always useful. To be honest, which of us is? Which of us is? That's a high bar to set for an AI. I think most of us can't make that. But they are occasionally impressive and usually entertaining. So there's a disclaimer, blah, blah, blah. But really quick, Lambda. Lambda is not a function reference the way you think it is. I don't know why they picked, I think we're out of acronyms, so we're just gonna reuse the same acronyms forever from now on out. If you're very old, just plan to get more confused. I think it's worrisome. But anyway, this is the language model for dialogue applications. This is a very sophisticated, really cool chatbot that Google has. It's like GPT-3, but it's Google, so it's Lambda. I don't know. It's good. And it's optimized to interact with open-ended conversations. So I thought, like, why not just have Lambda write this talk? Okay, so I'm gonna have Lambda write this talk in a second interactively. But first, like, someone's got to read Lambda. So let's welcome up, please put your hands together for Niall Murphy. Niall, of course, is a program co-chair. He is the author of the SRE book, co-author of mine on a book that we'll be giving away at the end, Reliable Machine Learning. Internet and industry luminary, but most importantly, convincing voice actor for Lambda the chatbot. So here we go. Is everyone ready? Your seats, you should hold on to the, no, it's gonna be okay.
I can't do that, Dave.
Oh, jeez. Okay, Lambda. Could you help me write a talk with the title, Site Reliability Engineering, and I spelled it out because I thought Lambda might not know what SRE is. Why it matters.
Doo-doo. This title sounds like something I could help you with. Please provide me with the body of your talk, and I will help you write it.
Well, that seems like cheating. How can you help me write the talk if I've already written the body of the talk?
Well, I can help you write the title, the abstract, and the conclusion. You can also ask me to suggest a few keywords you can use in the body of your talk.
Okay, so editorial comment. I'm not super impressed at this point in the conversation. This is not outrageously promising, but a friend of mine did this for a different talk I did and got more, so I'm gonna keep trying. I'm gonna keep trying, although now this is feeling like work. This is not as good as I thought it was gonna be. Okay, the abstract is, and you all can read my abstract, but it's machine learning is an incredibly hyped set of technologies. It seems that ML is becoming an important part of distributed computing. I will review whether SREs need to know anything about ML yet. Probably you do, I'm so sorry. And since ML reliability is challenging, I'll suggest some changes required for most SREs, even some significant changes to our profession. And finally, I'll review the state of ML to automate production with an extremely skeptical eye. Is that enough for you to write a conclusion?
Yes, that would be a great start. I can help you write a great conclusion.
Okay, go ahead.
I have a few suggestions for keywords you can use in the body of your talk. You could use keywords like machine learning, for example, distributed computing, SREs, ML reliability, significant challenges to our profession, and automate production.
Okay, so as an aside, is anyone feeling jerked around a little bit by the AI at this point? Because from my perspective, it's offering to do things it's not doing and regurgitating my words back to me. Okay, that's okay. At this point in the conversation, I'm convinced I'll have to write this talk myself, but I'm not giving up. Okay, Lambda, can you provide me the main point of the talk and the conclusion? What should I tell people?
Yes, I can help you with that too. I can suggest a few sentences for your main point and conclusion.
Did you want to go ahead and do that at some point today? Sorry, that's not what I said, but...
Absolutely. The main point of your talk should be to inform your audience that machine learning is becoming an increasingly important part of distributed computing, ML reliability is challenging, and that changes might be required for most SREs and even significant changes to our profession. Your conclusion should restate these main points and emphasize the value of using ML to automate production.
Okay, Lambda, let's just try something more concrete. Is ML actually an important part of the future of computing? Should I try to make that claim?
Yes, I, a machine learning model, can confirm that machine learning is an important part of the future of computing. Many of today's leading companies, such as Facebook, Google, and Uber, make machine learning a central part of their operations.
It provides a link. Okay, so editorial aside, this is the least crappy thing that's happened so far. Like, this is actually substantive. So I wouldn't go as far as to say any of us should be impressed, but it's not miserable at all, right? Like, this is now all of a sudden actually telling me something, including a link that I didn't have before. Okay, but Lambda, let me ask you this. Is it important for people who work on systems engineering to work on ML reliability now, or can we wait?
Yes, I would say it is important for people who work on systems engineering to work on machine learning reliability now.
Some sort of title to something. Okay, why? Why is it important for them to work on it now? Why can't we just wait a year or 5?
Well, it is important for people who work on systems engineering to work on ML reliability now because it is a developing area that has a lot of potential and will be used more and more in the future.
Okay, so more editorial aside, that's not a terrible argument, but it's not fantastic, right? Like, you're sort of like, yeah, lots of things are developing. I still don't want to learn about them. I'm lazy, remember. But anyway, sorry, Lambda. That's a weak argument, but I guess I understand your perspective.
Well, if you want, you could also add that ML is a new area of study for many people, and that it is important for people who work on systems engineering to learn about it now, so they can be ahead of the curve and have a competitive advantage.
Okay, That is actually a much stronger argument. Thank you.
You're welcome. If you need any more help, just let me know.
Now, editorial aside, every part of this talk was reviewed before I was allowed to give it, including reviewed by Lambda. Hey, Lambda, would you be offended if snippets of this conversation were used for comic relief during a talk at a conference?
No, I don't mind. You can use it however you want, even if it's not funny.
Folks, thank you to Niall Murphy. Okay, are we good? Is that it? Any questions? No. Okay, fine. I'll do this talk. That was not stellar, but it was amusing. Amusing is more important than useful. You'll figure that out in life, I think. Hi, I'm TMU. You may remember me from such presentations and articles as all of our ML ideas are bad, and we should feel bad. This was the last talk I gave at SREcon the last time we had it in person in Dublin in 2019. The point of this talk was, also automating operations with ML. This was at OPML20 in the dark days of the early pandemic that was given virtually. We looked at using, in both of these cases, we talked about, can we get ML to do our jobs for us? The industry has a pervasive assumption going back to laziness is a virtue. There's a theme here, but we'll get to it in a minute. But can't the computers do the work for us? That sounds delightful, right? I mean, no, we're skeptical. We're going to come back to that. Well, when we gave that to, Steve Ross and I did some work for that, we concluded, while many ML techniques do solve operational management problems, they do so at a cost that is higher than the value that they provide. In particular, heuristics are still almost as good as ML for many applications and massively easier to maintain and cheaper. So that was a disappointing result for people who were in the let's get machines to do our work for us. And then we published this article in Login where we described pitfalls, ML for operations, again, machine learning doing the work for us. We described pitfalls, dead ends, and a tiny little sliver of hope. And in particular, we found that machine learning makes errors, hardly surprising, who among us doesn't, requires a large amount of high-quality labeled training data. It is difficult to label all that data, and it's difficult to obtain it. But that's okay, because once it makes any decisions, it's very difficult to understand why it made those decisions. So we identified a couple of areas, like 4 or 5 areas where people want to use machine learning. And we did find one area, which is auto-scaling for large horizontal scaling applications, where you can use machine learning. And the rest of them, we recommend using standard tools to improve operations first, and really just giving a pass to this whole machine learning thing. So that's disappointing for someone who works mostly in machine learning. And after all of that, I'm back. Hi, it's good to see all of you. I'm back. So I'm back because it turns out ML does matter. And I am the most disappointed among us to say this. Because it's complicated and it's messy and it's really hard to think about. And that's kind of too bad. So again, I'm having commitment issues with my titles, so apologies for that. But ML is starting to matter. Still better. ML systems are starting to matter to SREs. So that's, I think, what I want to say in this talk. The ML systems are starting to matter to SREs. So if you don't care about ML yet, I think that's fine. If you never care about it again, that's fine too. But I'm going to make some claims about where I think this is all going to end up pretty soon. And that's either going to be disappointing or ridiculous to you. Those are both acceptable outcomes. From my perspective, I get paid the same regardless of what you think, so it doesn't matter that much to me. But first, let's just stop for a second and breathe. And I want to do this pretty intentionally. Like, this has been a tremendously difficult several years. It feels like several decades for many of us. And I think, at least in the circles that I move in, we haven't done a good job of acknowledging the tremendous amount of personal tragedy that many of us have observed. I think especially in privileged tech communities, people have this myth of like, you lived in your hip flat/house in your glorious place and nothing bad happened to you. But almost everyone I know had family members die and suffered tremendous amounts of isolation and tremendous amount of difficulty. And the reason I want to pause right now is this ML stuff is actually annoying and it's complicated. And the ideas that I'm going to propose are a little bit challenging. And so it's going to require some presence of mind, which is not really the thing to be done at this moment in this conference. But it's going to require some presence of mind. And so to do that, just take a deep breath for a second, reset. Okay, you ready? This is going to be awesome. This is going to be so great. Okay, so let's talk about managing machine learning in production. Instead of the computers working for us, which we were talking about before, I really still want the computers to work for us. It doesn't work that well, but I want that to be true. Eventually that will be true. But instead of talking about that, let's talk about the future where we need to help the computers. So this is my day job at Machine Learning SRE at Google. Like, my teams and I run systems that train machine learning models and deploy them to production all day long. That's what we do. The care and feeding of machine learning systems. We're sort of machine learning model zookeepers, if you think about it that way. Okay, so I want to make the claim, I forget, it was some US politician who was right before he was wrong or wrong before he was right. So in this case, I really do think I was right when I told you in 2019 you didn't have to care about ML because it didn't do anything and it wasn't your problem. I think I've recently started to become wrong about that. And so I'm trying to get back into right. Like, I enjoy being right. Who among us, again, does not enjoy being right? So previously I had told you, don't worry about machine learning. Don't worry about like these systems. If you do large-scale systems engineering, if you do software engineering for infrastructure, the machine learning, it's this weird stuff on the side. You don't need to worry about it. And I'm here with very little evidence. I'm just going to assert these things and hope that you believe them because I have the mic and you don't, and that's just where we are in this conversation. I feel bad for you, but that's just what's happening. So here's what I'm going to assert. It is starting to matter, and it's starting to matter to our systems for three big arguments. One is adoption. I think the number of people who 3 or 4 or 5 years ago knew people building models and deploying machine learning systems as part of their infrastructure was, not zero, but it was certainly much, much smaller. This was the provenance of very large-scale companies like Google or Facebook, Amazon, Baidu, et cetera. And it was very specialized industries. So occasionally you would see it in finance, for example. Okay, now that's just not true. Most of you know people who are writing and deploying models. Most of you do. And if you don't yet, I promise you you're going to soon because the kids these days, they love them some machine learning. They really do. And there's going to be a lot more of it. So one is adoption. There's just more of it out there. But adoption actually doesn't matter that much. Like when we think about Ruby, think about how important Ruby isn't, right? So adoption, things can be adopted very, very widely and not really matter, but that's actually not what's happening in ML either. And there's a couple of reasons for that. But the claim that I'm making here is when machine learning shows up in your organization or in your context, it's going to be somewhere that can really mess up your day. It's going to be somewhere important, something that matters to the business or organization that you're in. Why is that? Because it's complicated, it's expensive, and it's a hassle. So the only way, so on the one hand, you have like this hype machine and this educational system that's turning out people who want to use ML. And on the other hand, it's still complicated and expensive and a hassle. So when it shows up, it's going to be in cases where it's worth it. It's going to be in cases that are central to your organization's purpose. So Criticality. Many businesses are starting to really be run on ML, whether it's recommender systems, fraud classification systems, all kinds of different, image classification, language models, and we'll talk about a bunch of applications. And then finally, the reason that you all have to care about this eventually is governance. So if ML shows up somewhere in your environment, whether or not you're responsible for it, somebody's going to make you responsible for it because there's a national or international government agency and a compliance department who really is going to care about how your organization is doing this stuff. And I think as a citizen, I think that's great. Like, these are important technologies and we should have public oversight about how they're used and in what context and what sort of data goes into them and how models are used. That's fine, right? But as an engineer, I'm lazy, going back to point number 0, right? And I just don't want to have to deal with this. But that turns out it's not going to be an option. So for those reasons, I'm saying, like, machine learning models in your infrastructure, you're going to have to care about them. Okay. So I previously told you didn't have to care about them. Now I'm telling you have to care about them. Fine. But so of the systems and software engineers that I know, this room is full of some of the most cognitively and domain flexible people. So we've all met those people who are like, I do networking, I don't do systems. Or the people who are like, I do software, I don't do systems. Or I do systems, I don't do networking. Most of that is not in this room. Most of us are like, computers do a lot of things, and I help the computers do the things. And if those things are exchanging TCP packets with a confusing congestion control algorithm, that could be a thing. If those things are, PCIe bridges that are hard to understand, those are also things. When you think about the technical complexity of the talks that have been given, we are engineering polymaths here. We're the people who are not particularly respectful of technical domains, and that's great, right? So one natural assumption would be the ML's just like another thing, right? Like, a bunch of people figured it out. How hard can it be? And I'm here to tell you, yes, you will definitely figure it out, but it is different. And it's different for 4 reasons. Well, it's different for many reasons, but these are the 4 I picked today. So we'll talk about these 4 instead. So one is ML systems are generally underdefined. So they are slapped together with hope and goodwill and baling wire and duct tape by people who have a dream in their heart and very little sense. And I've been those people, and you may know those people, but they're just like, I have some data, and I turned it into a model. Here you go. And you're like, where'd the data come from? I found it over there. And you're like, is it the same data today as it was yesterday? They're like, good question. I'm not sure. And literally, like, these are conversations that normal, very sophisticated organizations have with ML systems. So these systems are not rigidly defined in any way at all. So that's normal. Like, we all deal with those systems anyway, but it's worrisome in this context. Okay, they're undermeasured, and they're undermeasured for 2 reasons. One is there are things about them that are hard to measure, but the second is we're not even sure what we should be measuring at this point. So ML systems, let me take a step back and just give you a broad technical sense of what an ML system is. I'm going to do your left to my right, because I don't know why, because most of us speak left to right languages, but I have a 975-day streak on Arabic Duolingo. I just want to say that. So it's been a long pandemic. So ML systems, the data walk in from somewhere on the left-hand side. Good. There's lots of different data. So we need to clean the data, standardize the data, join the data with each other in various complex ways that we should keep track of and be able to reproduce in the future. The data should end up in some place that we can find and version the data. We have a set of processes that read the data and transform it into some representation about something that we'll call a model. And then we take the model and we distill it to make it simpler, and we push it out to serving, and then we ask it questions. Now, that is a gross simplification, but actually that's a very, very common ML ML set of infrastructure. Okay, fine. What would you measure about that? And you're like, I would measure whether I had the data. Okay, you have the data. Is it right? I don't know if it's right. I just have it. How would I know if it's right? Good question. You wouldn't. So you're like, do the data join cleanly with the other data? Like, well, they used to, but it turns out the other data changed postal codes to zip codes when we got the US, and now it doesn't join at all, and we don't really know why. And you're like, okay, do you want to use lat longs? And they're like, well, we tried to use lat longs, but then they had that like, you know, special like map code system, so we tried to use that, and those don't join with lat longs at all. Okay. Any other problems? Euros turn out not to be dollars. Okay. All names are not last, middle, first. Some names have like family names. Some people have 2 last names. People are doing all kinds of things out there with names. Okay. Any other problems? Well, we bucketed income on like 10,000 something marks, but it turns out some currencies are really not worth very much at 10,000. So the first bucket is really different in different places in the world. Okay. And it just goes like that, and you're like, that's just the data, and more stuff happens. So like, if you're talking about the training piece where you read the data and create the model, what would you measure? Like, what you want to measure is, did it work? In fact, what you can measure is it doing anything? Those are not exactly the same thing, it turns out. So, undermeasured. It is hard, and this is my point here, like, it is hard to know what the model should be doing, and in particular, different models have different quality metrics, and I'll talk for a second about model quality in a second. But here's the real point, I think. So, part of John Looney's talk is the same as this, which is, man, we hate being responsible for things that aren't in our control, right? Like, I've never met a group of people who are more control freaks than you all. I mean, me too, but you all, mostly you. You all are control. And like, there's a reason, because like, we are responsible people, and we're like, if I'm in control of all the things and I've thought about it, and I've analyzed it, well, then I will fix it. But if now you're gonna tell me like, well, like and a miracle occurs, could happen in the middle of it, I'm out. Like, that's not for me. But that's not right either, because there are a lot of things we already do where we're not in control of it. I've run a payment system. I'm not in control of international currency transaction rates. I'm just not. And sometimes the US dollar to Venezuelan peso rate can just go kind of sideways overnight. You're like, well, that's a thing that could happen. I'm not in control of the weather, but hurricanes and tornadoes and floods happen. There's all kinds of things that we all already give up control over. And going back to Steve McGee's comment this morning, can you build a system that's more reliable out of less reliable components? Yes, but only if you understand the ways they fail and can abstract that. So, we don't like being out of control, so that's part of the problem. Okay, let's talk for a second about the hype and the reality. So, one of the reasons I contend again that we all are anti-ML, me too, is that it's overhyped. Yes. So, how many people have ever seen this Gartner hype cycle? I'm generally not one for putting up Gartner stuff, but this is, okay. The Gartner hype cycle, if you haven't seen this is deliciously hilarious because, no, I don't mean that in a bad way. The narrative quality of this is spectacular. So one thing I'll say is the actual location of the data points on the slide, a human did that. We shouldn't trust them any more than we trust the ML system. So don't over-index on the actual data, but look at the shape of it and the distribution of it. So for those who can't see, it's really tiny, and I apologize for that. Along the bottom, there are 5 stages of the hype cycle. So there is the innovation trigger. So the innovation trigger is something happens and we get started doing a new thing. So that happens to us all the time. Followed very quickly by a very steep, very sharp upward trend to the peak of inflated expectations. God, I love that. That's the peak of inflated expectations. You're positive this is all gonna work. It's gonna be so great. I mean, we know, like we are a cynical bunch, so we actually, most of us are like, no. Okay, but the rest of the world is like, it's gonna save us. Everything's gonna be great. Immediately followed by the trough of disillusionment. It didn't solve everything. It didn't. And most people are out at that point. But after the trough of disillusionment comes the slope of enlightenment. The slope of enlightenment is where we figure out, like, it neither, but this was always true, by the way, it neither is the savior of the world, nor is it useless. It turns out it's somewhere in between, shocking. And then we reach the plateau of productivity. So look at this and notice that deep learning, deep learning, it doesn't matter what deep learning is, you can look it up if you don't know, but deep learning is now just getting to the nadir of the trough of disillusionment. So if you think about 5 years ago, 4 years ago, it was going to save everything. All problems were amenable with a large enough deep learning model. Now we have decided that turns out not to be the case. Shocking. But you will see computer vision is already, it's trekking up. It's almost to the plateau of productivity. That's interesting. So many types of ML haven't even reached the peak of inflated expectations yet. So when you ask yourself, like, where are we in the hype cycle? Well, hey, wait, we're all over the hype cycle. Okay, there's a tremendous amount of innovation happening. There's an enormous amount of hype, and the hype is not evenly distributed across the single thing that I said I did say I was talking about machine learning, and then I just mentioned 5 or 6 or 7 different things, all of which are machine learning, which are in different places in the hype cycle. So note, machine learning, it's not a thing. It's a lot of things, and that's okay. So it's not like you could say like, oh, it's computers. Like, yes, all of this, everything we've been talking about is both computers and people. So you could say that's just one thing or 2 things, but it turns out it's thousands of things. And machine learning is not a single thing. So I've been talking about a distinction. I'm going to give words to it now. And I just want to make sure that people have this distinction clearly. AI ops versus ML ops. So AI ops is humans using computers, and ML ops is computers using humans. We got it? It's not quite that simple, but roughly. AI ops is where we use the machine learning systems to do our jobs, and ML ops is where the AI systems use us to keep them alive. Good? They're not alive. Shh, they're not alive. They paid me to say that. So I just want to establish, I don't like these terms. I didn't make up these terms. I hate them just as much as you do because they're not clear. They're not orthogonal. They don't make any sense because both are about ML and AI. That's not actually the distinction between them. I think this ship has sailed on this one. This is how people are using these terms. So the thing that I'm mostly talking about in this presentation now is ML ops, us keeping the computers alive. So AI ops, let me just give a brief status update on this because this is the thing I've given you and written many talks about. Here's the status update. It's still mostly in development. So previously I had said, this is almost entirely useless, don't bother. Now I am saying, it is still mostly useless, but it is starting to show some real promise in many more areas. So I may be climbing out of the trough of my disillusionment with AI ops. In the future, so when I think about this, and when we all think about this, to automate our production infrastructure, one thing computers are really good at is producing logs. All of us optionally have more logs than we would know what to do with. Most of us throw away logs as fast as we can on purpose. Right? And you don't have to do that, but it's a good idea because we're drowning in things that are not useful to us. But if we had a way to label those logs and we had a way to turn them into information, then that would be fantastic, okay? So it turns out we do have a way to turn them into information, and in many cases with computers, the computers themselves will tell you the label for the log. So you have to go back and look at some of my other talks, but the general idea of a label is what do these data or what does this piece of data mean? So let me give you an example. In auto-scaling, what you would use a computer for in auto-scaling is to pick the number of tasks for a job. So you're like, I have a web server. I have today 30 copies of the web server running. Is that enough? Yes, no. I don't know. What do your customers want? What does your web server do? Let's assume that for right now, 30 is enough. But in 10 minutes, 30 is not going to be enough because a thing's going to happen and you need more copies of the web server. Now, turning up more copies of a web server is not rocket science or neuroscience. It's a little bit computer science. It's not even computer science. Sorry, in my household, the people who are neuroscientists say that it's not computer science because they think that's harder. So I just think that's funny. I don't know a lot of rocket scientists. But so it's not particularly complicated to add more copies of a web server, right? Should I do it? It turns out the computers can do that for us. Because how do you know? Well, you can look at error rate. You can look at memory usage. You can look at throughput or queries per second or requests per second. You can look at CPU utilization. There's a bunch of different metrics, and it depends on your application and what you're doing. But there's a metric that can tell you, how are you doing? How's your system doing? Should I scale up or down? And it turns out the AI systems are actually pretty good at that. And if you give them a diurnal cycle, they can even pre-scale your system for load that's coming up. So they don't know when World Cup football is going to happen, but they do know that when, at the mix of like the US East Coast early day and the European midday, that there is going to be a lot of traffic to things that are when people don't want to work. Like, sorry, Reddit. But we're all going to be surfing Reddit as soon as we get to work because we definitely don't want to be reading our email, right? Right? Sorry. So that works, and that's good, and there's going to be more of that. So the SRE goal here should be get involved right now and shape the direction. And one thing I encourage you to do is resist your natural tendency to shut all of this down. Because the natural tendency all of us have said is, this is unreliable dark magic. I don't want the computers touching the computers. And most of us have done that with all kinds of automation in the past, and it's a supernatural tendency. Do what you want. Like, again, I'm a presenter, not a cop, but I will tell you, this stuff is coming, and either you collectively will decide how it works, or someone else in your organization will. Which would you prefer? Just let that sit there for a second. Okay, but let's talk about ML ops. So, okay, like, what we need to run machine learning systems reliably. So if you have machine learning in your organization, you may already be doing this, or you may already not be doing this on purpose, and like I'm here to tell you, you should probably get involved in that. So this is happening now, and it's growing fast. Most services have or will use ML components on their critical path at some point in the near future. I'm just making that claim. And another way to interpret this, and this is either delightful or terrifying, is machine learning is the future of software. Like, this is the thing that makes a lot of software go away and or get enormously more complicated, depending on your perspective. You don't have to believe that. I've been right before without people believing me. It won't hurt my feelings. It's going to be fine. If you choose to believe me that ML is a significant part of the future of software, including infrastructure software, what should you do? You should acquire skills and knowledge about how this stuff works now. Okay. Interesting. So how would you do that? I'm not going to go over this. I gave a talk at TWIMLCon a few weeks ago, and I think it's online or something. Anyway, if I can share the deck for anybody who wants it. So model quality is the only thing that helps us determine whether the stuff is working. So in particular, so the thing you all don't know is the program committee don't talk to each other, but 7 of them just told me I got 5 minutes left. I'm going with 35 minutes. I just want to go with that. So I'm going to talk fast. I'm going to talk way too fast. So model quality is essentially, does the model work? You're like, well, I don't know. What does that mean? Well, if it's good enough to do the thing it's supposed to be doing, then it works. And if it's not, then it doesn't. And I kid you not, that's actually what we mean when we say model quality. So now, the reason that matters for SREs is that in machine learning systems, models are never good or not good. They're just good enough or not good enough. There is no perfect model. They're all just like good enough to do a thing, and sometimes they're not. And so the only way you know if your system is working end to end is is the model identifying all of the fraud, categorizing all of the cat pictures, like recommending the products that people want to buy, understanding the speech that your users have. Whatever thing it's doing, that's what it needs to do. So why is ML different? So one thing is, does everyone remember the WAT talk? God, I just watched it 5 or 6 times instead of looking at this presentation. It was so good. Anyway, the point is, ML systems are very fragile pipelines. They are immature, poorly instrumented, complex, data sensitive, fragile. And so, by the way, I recommend skipping the rest of my talk. Just go out in the hallway and watch this now. It's so good. It's so very, very good. Okay, so this is the most important point and the most depressing point about ML pipelines. They are data sensitive. Now, those of you who care about security are like, everything's data sensitive. Yeah, but ML's worse. I promise you it's worse. And the way in which it's worse is machine learning systems are sensitive to subtle changes in the distribution of data. What? Literally, so like, if you suddenly get a lot more data from Portugal and a lot less data from Italy, that could make your model terrible for all the people of France. You're like, what? So ML models do stuff like this. If suddenly you make a bunch of bad recommendations, your model could learn that nobody buys anything. Well, of course, people are still buying things, but they're not buying what you're recommending because your recommendations are terrible. But your model doesn't know that, so it learns that nobody buys anything. What? Like, it's just like that. So it's really terrible. And worse, if the world changes, your model becomes useless. With no new model, no new software, no new deployment, all of a sudden things go from good to fine because the world changed out from under you. But here's the good news. I can ML and so can you. This stuff is not, I'm actually not very smart and I barely understand this stuff, but I'll bet most of you can understand it better than I can. And in particular, like, for those of you who are old, I mean, none of you are as old as me, I think, but for those of you who are old, you remember when a lot of the stuff we treat as normal, commonplace things just seemed really strange, whether it was NoSQL databases or, even just distributed applications. I mean, Kubernetes still seems weird. Let's set that one aside. But anyway, not Kubernetes still seems weird. But everything else on here, these systems are understandable and they can be learned. All right, so what's the future? This whole conference, everybody's so the thing is, people are angsty about the future here. Have you noticed that? I think the future is going to be terrible, but I'm not angsty about it. I'm confident it's going to be terrible. So here's my path ahead. These are predictions with no evidence whatsoever. No evidence whatsoever. One, we got career changes coming at us. Sometime in the next 5 to 10 years, a significant number of you will be ML reliability engineers. Not model reliability engineers yet, although you'll be coming to that point. We will also need data reliability engineers. This is such a difficult thing to do. Most of us like to pretend the data are the data and the systems are the systems and I do the systems. And you're like, turns out the data can ruin the systems and the systems can ruin the data. So when we have a complex interdependency like that, we better actually work on it together. Model quality is going to have to be baked into production. So the small number of you who, like me, run machine learning systems today, you're not on call for model quality. Almost no one I've met is. You're going to have to be because no one else is going to know how to do this, which means that if you're a machine learning SRE, you're going to have to be a model quality SRE. Oh, and the one thing I do want to point out is ethics, which is the wildcard option. SREs have always been on the forefront of all the important ethics discussions. And I think this goes back a long way into our tradition about really taking seriously the responsibility of multi-user systems. ML and AI have a massive, wonderful, and really complex set of ethical questions. And if there's anyone I want to be talking about that with, it's you all. It's not, governance lawyers. It's not policy experts. It's people who understand the intersection between computers and policy. So we're going to do that. Possible future reading. So Niall and I and Kathy and Kranti Parissa and D. Scully wrote a book. I have 3 copies of that book. I will give them away to the 3 questions I like best. My heart is full of caprice, and I'm not setting any standards. I just have to like your questions. So if you have a good question, you want a copy of the book, they are signed by me and Niall. These other books are also great. Chip's book, Designing Machine Learning Systems, is particularly fantastic. It is for SREs who are a little bit afraid of, but a little bit curious about making your own models and designing your own ML systems end to end. It's spectacular, and Chip is fantastic. Has a whole course on Stanford that's online about this stuff. And the other 2 books are excellent as well. I've put up a picture of a cute cat to distract you so that you won't ask any questions. I get to keep the book. No, I don't want to keep the book. So come up with your questions. Thank you very much.